Chapter 5.3, use angle bisectors of triangles. So you want to remember that an angle bisector, that divides an angle into two congruent adjacent angles. Okay, so it basically cuts it into two halves. All right, so remember bisect means to cut in half. Okay, we can see these two angles down here are congruent. You see this mark right here and that mark right there. This angle matches this angle. Okay, so this ray right here is cutting this angle P in half. All right, so that ray is an angle bisector. And remember, when you name the ray, the endpoint letter is first, so P is the first letter. And then you pick another point on the ray, so that's point S. And when you put the arrow over the two letters, it always points to the right. So ray PS is the angle bisector. All right. And remember, when you do the distance from a point to a line, so if you want to go from point S to this ray right here, it has to be perpendicular. So this piece right here, this line segment here in blue, and you see it makes a right angle right here. It's perpendicular. This right here is the distance. And that is from point S to this ray right here. Same thing on the other side. This is the distance from point S to this ray. It has to be perpendicular. All right, angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from two sides of the angle. Okay, equidistant, remember that means the same distance. All right, so equidistant means same distance. Okay, so once again, we can see angle A right here, it's bisected or cut in half. This angle right here is congruent to that angle right there. Okay, the angle is cut in half or bisected. And this ray right here, this ray AD is the angle bisector. So ray AD is the angle bisector. Okay, so this ray is what is cutting this, is bisecting this angle here. And if you go along this ray and pick a point on the ray, say point D is going to be the same distance to both sides of this angle. So DC, this distance right here, is going to be the same length as DB. All right, so DC equals DB. And that is because D is equidistant to ray AB and AC. So this is AB and this is AC. It's the same distance to both sides. Okay, the converse of the angle bisector theorem, if a point is in the interior of an angle and is equidistant from the sides of the angle, then it lies on the bisector of the angle. Let's take a look. Okay, so here we have this angle right here. All right, and here we have point D, and point D is the same distance to the rays that make up the angle. Okay, this distance here is the same as this distance here. So DC equals DB. So I'm going to say, since DC equals DB, then point D is on the angle bisector. All right, so the angle bisector here is this ray. Okay, so the angle bisector is ray AD. All right, remember the ray. You start with the end point and then you pick another point on the ray. you put an arrow pointing to the right over the two letters. So since DC is DB, that means this point is on the angle bisector. And since this is an angle bisector, that means this angle here is going to match this angle here. Those two angles are congruent. And the reason I know these two segments are the same distance, this mark here is marked congruent to that mark there, and they both make right angles with the ray. Example 1, find the measure of angle GFJ. All right, they want us to find angle GFJ. So that's going to be this angle right here. All right, so how do we find that? Well, let's see. If you look at point J, it's the same distance to both sides of the angle. See this distance right here? That's 7. This distance right here, that's 7. And as a result, we know that J is on the angle bisector. So if this is an angle bisector, that means this angle is being cut in half. So if this one is 42, this one also has to be 42. So the measure of angle GFJ is going to be 42 degrees. And that is because J is equidistant to the sides of the angle. All right, since J is the same distance to both sides of the angle, we know that it's on the angle bisector. All right, example 2, a soccer goalie's position relative to the ball and goalpost form congruent angles as shown. Will the goalie have to move farther to block a shot to the right goalpost or the left goalpost? All right, let's see the diagram. All right, so here is the kicker. Okay, he's kicking the soccer ball. We can see these two angles right here. All right, that one there and that one there are marked congruent. So, will the goalie have to move farther to the left or right? Well, since these two angles are congruent, this line or ray right here is the angle bisector. Okay, and we can see the soccer goalie is on the angle bisector. So that means he is going to be the same distance to the right side and the same distance to the left side. Okay, so he's already right in the middle. He does not have to move farther to the left or right. Remember, if the point is on the angle bisector, then that point is the same distance to both sides of the angle. So the goalie must move the same distance to block either shot. Example 3, for what value of X does P lie on the bisector of A? Okay, so here is the distance to both sides of the angle. Okay, they used algebra expressions. And in order for point P to be on the angle bisector here, all right, this would be the angle bisector. In order for P to be on that angle bisector, the distance to either side of the angles has to be the same. So this would have to equal that. Please set them equal and solve for X. All right, so we have PB equals PC. So PB is X plus 3. And PC is right here, 2X minus 1. Solving for X, I like to subtract the smaller x, and it cancels here. 2x minus x is x, and we want to get rid of negative 1. So the opposite would be positive 1. And 3 plus 1, of course, is just 4. So that's it. They only ask for x. If you wanted to plug it in, 4 plus 3 would equal 7. And 2 times 4 is 8 minus 1. That would also equal 7. But they only ask for x. But of course, you want them the same number. They should be the same distance. All right, please try number 1. See if you can find the value of x. All right, we can see right here, this line or ray is an angle bisector. How do I know? Because 27 equals 27. This angle here is being bisected. Because of that, this point that's on the angle bisector has to be the same distance to both sides. So x is just 15. All right, see if you can solve for x in number 2, please, and I'll give you a hint. These are both in degrees. So these algebra expressions represent this angle here and this angle here, okay? And those angles are going to be congruent, so just set them equal. Okay, now because these two distances here are the same, that means this point lies on the angle bisector because it's the same distance to both sides. And if this is on the angle bisector, that means this angle here is being bisected. So these two angles match. So 3x plus 5 is going to equal 4x minus 6. Okay, solving for x. I like to subtract the smaller x. So 3x is less than 4. 3x minus 3x is gone. 4 minus 3 is 1, so that's just 1x. And negative 6, I want to move that over. The opposite is positive 6. 5 plus 6 is just 11. All right, please try number 3 real quick, and I'll give you a hint. You can see this angle down here is bisected because this half matches this half. See, they are marked congruent, and that means this right here is the angle bisector. Okay, this ray is the angle bisector. As a result, any point that's on that ray has to be the same distance to both sides of the angle. So this segment here is congruent to this segment here. So you just set the segment lengths equal and solve for x. All right, pretty easy. 5x equals 6x minus 5. All right, solving for x. I'll do minus 5x on both. All right, this cancels, and that's going to be 0 equals x minus 5. And, of course, if you do plus 5 on both sides, 0 plus 5 is just 5. All right, so the reason these theorems work is because of congruent triangles. If you go back to the first theorem, this side right here, we have two triangles. This side right here is shared by both triangles. Okay, and then we have angle, angle, side, angle, angle, side. The side is not in between the two angles. So those triangles are just congruent by AAS. All right, and in the second theorem, again, we have two triangles. Mark the side that's shared by both triangles congruent. Now, if you go, this is a right triangle. If you will go across from the right angle, that's your hypotenuse, and any other side on the right triangle is called a leg. All right, so this right here is the leg. So these triangles are congruent by hypotenuse leg. All right, let's see. Do you have enough information to conclude that QS bisects PQR? Explain. All right, let's take a look. So they're asking us if QS bisects PQR. In other words, they're asking if this angle matches this angle. Okay, see if you can prove the triangle's congruent. That's my hint. So if we were to try to prove these triangles congruent, the first thing I would do is mark this side that's shared by both triangles. Okay, now we don't have any angles that are given to be congruent. So all we have is side on both of them. We don't have right angles, so we can't use hypotenuse leg. So all we have is side. There is nothing where it's just side. So we cannot prove these triangles congruent. Therefore, we cannot prove that this angle matches this angle. So the answer is no. Okay, not enough information. Okay, theorem 5.7, concurrency of angle bisectors. The angle bisectors of a triangle intersect at a point that is equidistant from the sides. All right, let's take a look. Okay, so these red line segments are the angle bisectors. See this line segment here? So they're saying this angle matches this angle. This one here in red, they're saying this angle matches this angle. And also this one here in red, they're saying this angle matches that angle. Okay, so the ones in red are the angle bisectors. And remember, the angle bisectors all meet at the same point. As a result, if you go from that point to any one of the sides of the triangle and make the right angle, make it perpendicular, those are all going to be the same distance. So PF, PE, and PD are all the same length. All right, PF, PE, and PD are all equal. That's because they are the same distance to each side of the triangle. Point P is the same distance. Okay, the point of concurrency of the three angle bisectors of the triangle is called the incenter. Let's take a look. So this point P right here, where all of the angle bisectors meet, that is called the incenter. That's where all the angle bisectors meet. All right, because the incenter P is equidistant from the three sides, a circle drawn using P as the center and the distance to one side as the radius will just touch the two other sides. The circle is said to be inscribed. All right, let's take a look. So here they're using a compass. So this point is where all the angle bisectors meet. And if you drew a circle using that point as the center, and if you drew it the right size, the correct size, the circle would just hit each side of the triangle. Okay, so you use the distance here from the center to the side of the triangle. That's going to be your radius, R. All right, and if you draw the circle, this is what it would look like. So right here, the circle is inscribed in the triangle. Okay, you can see this was the point, the incenter where they all meet, and this is the circle. See, it just touches one side, each side of the triangle. Example 4, the diagram N is the incenter of ABC. Find ND. Let's see. Okay, they said point N right here is the incenter of the triangle. Okay, so I will label that as the incenter. Okay, and remember the incenter is the same distance to all three sides of the triangle. So this distance here, see, it makes the right angle. This distance here makes the right angle, and this distance here, they are all the same. All right, so they want us to find ND. Okay, so ND is this one right here. And we don't know what that is. But since all these blue segments are the same, we can find any one of them in order to find ND. Now, if you look here, there's a right angle. So this right here is also a right angle. So this right here is a right triangle. So in order to find a missing side length, we use Pythagorean theorem. We can use a squared plus b squared equals c squared. Okay, remember c always has to be the hypotenuse. So if you go across from your right angle, that one has to be c. All right, so since c is 20, in place of c squared, I'm going to make it 20 squared. Now, this side here is 16, and this side here we don't know. So the other two sides are a and b. It doesn't matter. So I'm going to let 16 equal side length b. And this side here, I'm going to make that side length a. All right, we don't know a, so I'm going to leave it as a squared. And b is going to be 16, okay? Should have wrote it like that. So b is 16, and b squared is going to be 16 squared. Okay, so we have a squared, and 16 times 16, that's 256. And 20 times 20 is 400. Okay, solving for a squared, I'm going to do minus 256 on both sides. Cancels here. Bring down your a squared, and that is going to equal 144. All right, the opposite of squaring something is square root. So I take the square root of both sides. The square root of a squared is a. Square root of 144 is 12. Okay, you don't want to use negative 12. Even though it works, you can't have a negative side length. So a is 12. All right, so if this side is 12, then this one here is also going to be 12. All right, and that's what they wanted us to find, ND. All right, so if that one's 12, then ND is also going to be 12. Final answer. All right, so basically I just made a right triangle and used Pythagorean theorem. Okay, let's try number 5. It says in example 4, suppose you are not given AF or AN, but you are given BF is 12 and BN is 13. Find ND. All right, I'm going to write all this stuff on the diagram. All right, it says you are not given AF or AN. So first, I'm going to erase those two because it says you're not given those two numbers. All right, and it said BF is 12 and BN is 13. And again, they want us to find ND. So that's this one right here. All right, I'll give you a hint. If you find NF, you also have ND. So use Pythagorean theorem right here. You may have to round to 1 decimal. I'm not sure. Okay, so we know that this is the in-center, so that means ND is the same length as NF. Okay, so if I can just solve this, I'll have this. All right, we have a right triangle, so I'm going to use a squared plus b squared equals c squared. And I'm going to use this triangle right here. Across from my right angle is always the hypotenuse. That's going to be c. So c is 13, and c squared is going to be 13 squared. All right, the other two sides, it doesn't matter which is A or B. So I'm going to let 12 equal the B. And I'm going to let the missing side equal the A. So we don't have A. So I'll leave it as A squared. And for B squared, that's going to be a 12 squared. All right, we have A squared. 12 times 12, that's not equals, that's plus. 12 squared, or 12 times 12, 144. 13 squared is 169. Okay, the opposite of plus 144 is minus 144. And it cancels here. Bring down your a squared. 169 minus 144 is 25. Okay, the opposite of squaring something is to take the square root. So a is just 25. All right, you don't want to use square root of 25 is just 5. And you don't want to use -5 because we're dealing with side lengths here. All right, so a is 5, which means this side is also 5. So ND, or DN, either way, is going to equal 5. Final answer. Okay. If you want to do this quicker, you can just let the calculator do the work. Subtract 12 squared from both sides, and then you would do the square root of 13 squared minus 12 squared. Okay, some people could just cut to the chase and do it the shorter way if you want to do it that way as well. But I multiplied each number out and just solved it manually.